Lesson 9.5 is about inscribed angles. Okay, first of all, what is an inscribed angle? An inscribed angle is an angle formed by two chords inside of a circle, and the vertex of the angle is on the circle itself. So angle 1 that you see in the diagram here is an inscribed angle, and the measure of angle 1, the measure of the inscribed angle, is always exactly half of the measure of the intercepted arc. So in this diagram, angle 1, the measure of angle 1 is equal to 1/2 of A, whatever that arc measure is. A corollary to that theorem is that if you have two inscribed angles in a circle and both of those inscribed angles happen to intercept the same arc, then those two angles must be congruent to each other. So in this case, the blue inscribed angle, angle 1, and the green inscribed angle, angle 2, are both intersecting that red arc. So angle 1 and angle 2 are the same measure. They are congruent. Another corollary of the first theorem is that any angle that is inscribed in a semicircle, if you think about it, it's cutting off a 180-degree arc. It's cutting off half the circle. So the measure of that angle is always 90 degrees. That's always a right angle. So whenever you have, it looks like a triangle there, but an angle inscribed in a semicircle, it's a right angle. The last corollary to that first theorem is that whenever you have a quadrilateral that's inscribed in a side of a circle, then the opposite angles, each pair of opposite angles, have to add up to 180 degrees. They're supplementary. Because if you think about it, the quadrilateral, the sum of the angle measures has to be 360 degrees. And every one of those inscribed angles has to add up, has to be half the measure of the intercepted arc. So we'll end up with sets of angles, opposite sets of angles, adding up to 180 degrees. Okay, then the last theorem is that when you have, it kind of looks like tongs, a pair of tongs, but when you have an angle that's formed by a chord inside of a circle and a tangent to the circle, like the previous theorem, that angle is measured to half of, that angle measure is equal to half the intercepted arc. So in this case, the measure of angle 1 in the diagram is equal to 1/2 the intercepted arc A. All right, now for a few examples. In the first examples, I have three inscribed angles. One's 38 degrees, one is x degrees, and one is y degrees. Well, what I have to notice when I want to find x and y is that the 38-degree angle, if I go from where that intersects the circle, cuts off this arc that I've got in red. Well, notice that angle x also cuts off the same arc, and angle y also intercepts the same arc. So angle x and angle y are exactly the same arc as the 38-degree angle. So angle x and angle y are both 38 degrees. Okay, in the next example, I also have to solve for the degree measures of x and y. So I notice that what I have here is a triangle inscribed in a semicircle. So one thing, and I know it's in a semicircle because the one side of that triangle goes through the is a diameter that goes through the center. So what that means is that this inscribed angle right here is a 90-degree angle. So now I know that x and y have to add up to 50. And I look at x, I notice that x intercepts the arc that is a measure of 50. So x is 1/2 of 50 degrees, or 25 degrees. And then angle y is the complement to 25 degrees. So it's 90 minus the 25 degrees, or 65 degrees. Okay, in the next example we have a quadrilateral inscribed in a circle, And we know that opposite angles are supplementary when we have a quadrilateral inscribed in a circle. So to find x, x is going to be, x and the 110 degrees have to add up to 180. So x is 180 minus 110 degrees, or 70 degrees. And then y is opposite the 85 degree angle, and it has to be supplementary to that. So y is 180 minus 85 degrees, which is 95 degrees. Okay, in the next diagram I want to find x degrees and y degrees. X is an intersected arc. So I look to the 60 degree angle that's inscribed and cuts off that arc. So I know that 60 degrees has to be half of x, or x has to be 2 times 60 degrees. So x is 120 degrees. Then to find angle y, I know that when I look at this chord and this tangent that intersect like a pair of tongs, I know that angle y, the measure of angle y, which I've got in green right here, should be equal to half the measure of that intersected arc. We just found that that intersected arc is 120 degrees. So y should be half of 120 degrees, or 60 degrees. Alright, in this next example I have this triangle that's inscribed inside of a circle, but it's not a semicircle, and one of the corners of the triangle has a tangent, a green tangent, at that same vertex, and there's also an angle y there that's formed by a chord in that tangent. So first of all, I'm looking around and I see that the 40 degree angle right here is an inscribed angle, and it intersects this red arc right here. So I know that that red arc must be 80 degrees, because it's twice the inscribed angle of 40 degrees. Now if that's 80 degrees, I now know that that angle y is also equal to half that same intersected arc. So y should be also equal to half of 80 degrees, or 40 degrees. Now angle x is an inscribed angle that cuts off this arc, and this is the remaining arc to complete the whole circle, because I have a 150 degree arc, an 80 degree arc, and the green arc. So if I add up the 150 and the 80 degree arc, that's 230 degrees. Okay, so when I take that away from the full angle measure, the full circle of 360 degrees, I'm left with 130 degrees that has to be the measure of that arc. So if that's a 130 degree arc, then angle x is the inscribed angle that intercepts that arc. So x should be 1/2 of 130 degrees, or 65 degrees. Okay, and this last one's pretty easy. I have an isosceles triangle inscribed in a circle. I can see that the base angles x and y will both be the same measure, and so I'm looking for this the measure of that angle up at the top, and I can see that that angle cuts off this arc right here, intercepts this arc, which is 80 degrees. So that means that angle up at the top has to be 40 degrees. So if that's 40 degrees, it means that the other 140 degrees has to be divided evenly between angle x and angle y. So 140 degrees divided by 2 means each of angle x and angle y are 70 degrees. And that's it for this lesson.